Hello everyone, this is Dr.G. Karthik Reddy working as Associate Professor in the Department of EC, MLR Institute of Technology, Hyderabad. In this session, we are going to discuss the relationship between cross power density spectrum and cross correlation function. Okay, in this session, we are going to discuss cross power density spectrum, cross correlation function and the relationship between them. Okay, we are having first we will discuss the statements related to this. S xy of omega represents cross density spectrum. R xy of tau represents cross correlation function. Okay, then what we are going to discuss the relation. Okay, R xy of tau and S xy of omega form a Fourier transform pair, or S xy of omega form a inverse Fourier transform pair to the R xy of tau. Now next we are going to discuss about S xy of omega is equal to integral minus infinity to infinity R xy of tau e power minus j omega tau d tau, or R xy of tau is equal to integral minus infinity to infinity S xy of omega e power j omega tau d omega. These are the two important statements. Okay, these are the statements related to this relation. We are going to prove this one, or we can also summarize that the time average of cross correlation function is called cross power spectral density. Okay, this concept comes from the Vernier-Kinchy relation, that is the relationship between power spectral density and autocorrelation function, both form a Fourier transform pair. From that we are having the extension that is called for cross power spectral density and cross correlation function. Now we are going to prove this statement. Okay, same. Okay, here we are having that. Okay, time. Okay, this is the time average of autocorrelation function, or here you are having cross correlation Rxy. Rxy represents cross correlation t comma t plus tau, which is equal to 1 by 2 pi integral minus infinity infinity S xy of omega e power j omega tau d omega. Now next, this is inverse Fourier transform. For Fourier transform relation, S xy of omega is equal to integral minus infinity infinity, okay, time average of R xy of t comma t plus tau into e power minus j omega tau d omega. Now you are having one more relation related to the cross power spectral density. S xy of omega is equal to limit t tends to infinity expectation of xt of omega into conjugate, this is conjugate into yt of omega by 2t. Okay, you apply the relation xt of omega is equal to integral minus t to t x of t1 e power minus j omega, okay, e power j omega t1 dt. Okay, here we are having conjugate, that is why minus sign is neglected to plus sign. Okay, x star of omega. Next, yt of omega equal to integral minus infinity infinity y of t2 e power minus j omega t2 dt. You substitute these two here for x star of omega equal to integral minus t to t x of t1 e power j omega t1 dt. Okay, now substitute that. Now apply the expectation, limit t tends to infinity 1 by 2t expectation of the first term and second term. Now expectation is always applicable to the random process. Okay, the random process is expectation of x of t1 y of t2. Next, simplify it further, e power j omega t1 minus t2 dt1 dt2. Now next, limit t tends to infinity 1 by 2t integral minus t to t of two integrals. Okay, this relation represents what? Cross correlation function Rxy of t1 comma t2. Okay, t1 comma t2, this is a cross correlation function e power j omega t1 minus t2 dt1 dt2. Next, 1 by 2 pi integral minus infinity infinity, this one represents, okay, this one represents cross correlation function. Okay, take this one. Next, what we want, we require the 1 by 2 pi integral minus infinity to infinity sxy of omega e power j omega. Okay, you have to substitute this sxy of omega. Sxy of omega is this concept. You substitute that in the here. Now next, when you substitute here j omega, e power j omega tau, e power j omega tau plus t1 minus t2. Okay, when you substitute j omega tau plus t1 minus t2. Okay, you are having this part whatever we discussed, this is the sxy of omega. Sxy of omega. Okay, sxy of omega we have substituted. Now rearrange the terms. You take 1 by 2 pi. Okay, you take the limit part separate, then 1 by integral minus t to t, integral minus t to t, rxy t1 comma t2. Okay, here what you are having 1 by 2 pi integral minus t to infinity e power j omega tau plus t1 minus t2. This part is left. Okay, this part is left. Now we have to simplify this part. Okay, we know the definition from the impulse signal that del of t, when you apply the Fourier transform, which is equal to 1 by pi. Okay, then what you have to get now, same thing. Okay, impulse signal, when you apply the Fourier transform, that is equal, resultant is 1. Then integration minus infinity infinity del of t in place of x of t equal to del of t. You know the formula. Okay, and simplify it, then you will get 1. Area under the curve of impulse signal is always 1, or del of t equal to 1 by 2 pi integral minus infinity infinity e power j omega. Based on this relation of equation 2 is similar to the equation 1. Both are same. In place of t, you are having what? Tau plus t1 minus t2. That you replace with delta. Okay, delta of t is e power j omega t. Delta of t plus tau plus t1 minus t2 is e power j omega tau plus t1 minus t2. Okay, you have to substitute this. Now next, what you have to get? Okay, you have to substitute del of tau plus t1 minus t2 dt1 into dt2. Now if you substitute it, what you are going to get? Now this part, what you are having that relation, the previous part, you are having this. In place of this, what you are having? Del of tau plus t1 minus t2. Okay, this part is eliminated. Now resultant, what you are going to get? Del of t equal to 1 by 2 pi integral minus infinity to infinity. This part you are going to get. Okay, that part is erased. Now next, limit t tends to infinity 1 by 2t integral minus t to t. Now this is autocorrelation function, cross correlation function. You consider t1 equal to t, t2 equal to t plus tau. Okay, or here you are having t2 equal to t1 plus tau, t2 equal to t1 plus tau, t1 plus tau. Okay, then del of t2 is differentiation of t2 will be eliminated. Then next, what you are having? Substitute t1 equal to t, t2 equal to t plus tau. Then you are going to get rxy of t comma t plus tau dt. Okay, next, this is A represents time average of cross correlation function, which is equal to, this is a relation of cross power spectral density. Okay, time average of cross correlation function and cross power spectral density cross PSD form a Fourier transform pair. Or you can take the reverse manner, that is power spectral density is equal to integration minus infinity the time average A of rxy of t comma t plus tau is equal to into e power minus j omega tau d tau. Okay, this is an important relation for understanding the concept of cross PSD and cross correlation function. Okay, cross correlation function. Now next, we take one example related to this concept. Okay, before the example, first you have to know the formula. Okay, this is a relationship between this. Now if they ask in the exam point of view, like the question, okay, example, Rxy of tau. They will give the input as Rxy of tau. They will give this as an input. We are going to identify the output. Okay, if you understand the concept of the definition, then it is easy to solve. Okay, then which is equal to, okay, AB by 2 sine omega and tau cos omega naught 2t plus tau. Then what you have to do? Okay, whatever the formula you are having, you have to substitute it. Okay, limit t tends to infinity 1 by 2t time average. Okay, one integral minus t to t rx by t comma t plus tau dt. This is a definition. Okay, just now we have discussed, this is the time average of that. First you have to simplify this one. Okay, to simplify this one, first AB by 2 sine omega naught tau, AB by 2, apply the limits, limit t 1 by 2t minus t to t, because it is a function of t, not function of tau. Function of tau is a constant. Now what you are going to get? Okay, this is similar, we are going to get AB by 2. Here you are having the integration, you apply it. Okay, so cos, in terms of cos you are having 2t term, 2 plus tau. Then if you simplify it, e power j omega tau minus e power minus j omega naught tau by 2j. Okay, 2j means 2 to integrate multiplied 4j you will get. Okay, now next, now whatever you are having cos term, okay, cos term is applicable repeating multiple times. Okay, this term, whatever you are having, this term, whatever you are having, you are getting cos t, and then 2t will get cancelled. Now resultant you won't get, this term will become 0. Then next what you are having, only this term is left. Only this term is left. AB by 2 sine omega naught tau, that is sine omega naught tau. If you expand further, then what you are going to get, e power j omega naught tau sine omega naught tau, which is equal to e power j omega naught tau minus e power minus j omega naught tau by 2j. Okay, multiply it, you will get AB by 4j e power j omega naught tau minus e power minus j omega naught tau. This term you are going to get. Now this one you expand it further. Just now we have discussed del of t equal to 1 by 2 pi integration minus infinity infinity e power j omega tau d. Integration minus infinity e power j omega t d omega is equal to 2 pi into del of t. Okay, here you can substitute here del of omega. Okay, integration minus in, okay, this part here only you are having, this part separate, 2 pi del of omega minus omega naught minus 2 pi del of omega plus omega naught. Okay, you take 1 by j. 1 by j is equal to j power 4 by j power 4 equal to 1. J power 4 by j, that is j power 3, that is equal to minus j. Okay, minus j pi. Okay, you take the pi constant. Okay, pi take common into AB by 2. Okay, 2 gets cancelled. AB by 2 del of omega minus omega naught minus omega plus omega naught. Okay, now here this is a mathematical representation. Graphical representation is, they are having omega. Okay, here they are having del of omega minus omega naught. They are having del of omega plus omega naught. The magnitude you are having pi AB by 2. Pi AB by 2. Okay, in this way you have to solve the problem related to the cross PSD and cross correlation function. Okay, they may give either, okay, in the form of xt of t. Okay, here also first you have to take the x of t, whatever the x of t and y of t, two signals, two random process they will give. First you have to convert into cross correlation function. Then after converting that, you can apply the power spectral density. This is another method to solve it. Okay, to solve this approach. Okay, now next you can also use limit tau tends to infinity 1 by 2t expectation of xt star of omega yt of omega. Okay, you can use this approach also to solve the problem of cross power spectral density. Okay, you can use either the first approach. First approach is, first they will give the signals x of t and y of t. First you have to convert in the cross correlation function. After converting the cross correlation function, then substitute in the relation of the cross correlation function and the power cross PSD form a Fourier transform pair. You have to use the relation and you have to substitute, then you will get the cross PSD. After getting cross PSD, if they ask the average power, then also you can substitute in the average power. Average power is what? Area under the curve of cross power spectral density is called average power. Okay, average power. You can use either this relation or this relation. Then after that, you substitute in the what is that, and the area under the curve of the power cross PSD. Area under the curve of cross PSD is called cross average power. Then we will get this relation. Okay, all the problems they will give you similarly. X of t may be, X of t and Y of t may be either deterministic signal or non-deterministic signals. Okay, they may give anything. First you have to convert this one in the form of correlation, cross correlation function. After that we have to convert in the form of cross power spectral density function. This is one of the easiest approach for solving for the cross power spectral density. Okay, these are some of the problems related in this session. We already discussed that the relationship between cross power spectral density and cross correlation function. Okay, this is the relation. Okay, the time average of cross correlation function and the cross power spectral density form a Fourier transform pair. This is one of the important relation to solve the cross power spectral density. Thank you.